let us proceed with our second part of our discussion. So tumeona kwamba this kinetic molecular theory ameelezea what happened to the gas particle ambapo it lead to the change in gas volume when the pressure change. Tukaona kwamba also this theory clarified the contribution of each individual gas to the total pressure as stated by Dalton law. So the increase in volume due to an increase in temperature as stated in Charles law is also part of this theory. Sasa utakuja kuona hapa kote anajaribu kuunganisha zile ideas za zile law. Uone kwamba sasa huyu kinetic theory yeye anakuja kufanya clarification more. Ndio maana anasema kwamba also the increase in volume due to an increase in temperature as stated in Charles. Kwa sababu tuliona kwamba katika Charles law volume is direct proportion to the to the absolute temperature at constant pressure and the number of particles. So the dependence of the gas volume or pressure on the number of moles present and not on the nature or size of the gas molecule is also explained by the kinetic molecular theory of gases. Kwa hiyo hapa ndo tunakuja kuangalia kumbe hii yote ilikuwa ni just the scenario ambayo inaonyesha namna gani kinetic molecular theory inajaribu kubase. Kwamba utaona kwamba all concept are tried to explain all this concept hawa wataalamu walijaribu kuzielezea kwa namna moja au nyingine, lakini the kinetic molecular theory anakuja kufanya more clarification kwa kuangalia the molecular level. So now let us see this assumption of the kinetic molecular theory. Assumptions of the kinetic molecular theory. Tunaposema assumption ni kama postulates. The following assumption or postulate of the kinetic molecular theory of the gases. Kwamba theory yote ile huwa inatoa suggestion. Ni kama maoni. It's like postulate, assumption, makisio. So let us see the assumptions of the kinetic molecular theory of the gases. Hili ni swali lako unaulizwa mpaka kwenye NECTA. So be careful. The first assumption of KMT or kinetic molecular theory was a gas consists of very small particles called atom or molecule scattered throughout the container. Kwamba gesi imeconsist very small particle. The same you can say tiny particles. What are those tiny particles? Unarudi kwenye concept of the atom. Ulisoma form 2 what the atom. Kwa hiyo unaona kwamba gesi zimeconsist hizo very small particles ambazo zinaitwa atom, or sometimes you can call it molecule. Hamna tofauti ya atom, molecule, all these are elementary entities. Kwa hiyo unaweza ukatumia atoms or molecule whatever. And these small particles are scattered throughout the container. Ndio maana gesi hatujui kwamba au hatuwezi kusema kwamba inachukua tu sehemu fulani ya container. Instead ndani ya container inakuwa inasambaa humo. Inakuwa ina-occupy the space of the whole container. Haiwezi tu kufit sehemu fulani. This is the first assumption. So due to their small size, the volume of individual gas molecule is negligible compared to the volume of the container. You see? Kwamba gas imeconsist very small particle. Tunaposema very small particle maana kwamba it is thin particle. Sasa anasema kulingana na size yake kuwa ndogo, small size of this gas particle, anasema the volume of individual gas molecule is negligible. Kwa hiyo volume ya individual gas is negligible compared to the volume of the container. Tunaposema negligible maana kwamba inaweza kawa approximately to zero. Tunaposema negligible, something negligible ina maana ni kitu ambacho kinaweza kuwa sasa na zero kwa sababu ni very very small. Second assumption is gas molecules are in constant random motion and travel with uniform velocity whose direction changes on collision with other gas molecule or with the walls of the container. Taona kwenye figure 1.13 ipo mwishoni kabisa nimeiweka. Kwa hiyo unaona kwamba gas molecule are in constant random motion. Tunavyosema kwamba constant random motion maana kwamba zinakuwa zina move randomly. Ndio maana anasema and travel with uniform velocity, kwamba zote zinakuwa na spidi moja, the same velocity, lakini zinakuwa katika nini? Random motion, they move randomly. Hatuwezi kusema kwamba gesi inaweza ikawa na direction moja. Instead it is spread or it move randomly within the container while their motion occupy or exist the uniform velocity. So you have to note this, ambayo hii direction yake change on collision. Wale wa physics mtaelewa kuhusiana na the issue of the collision. Okay. Assumption number 3, it is stated that all collisions between gas molecule are perfectly elastic. Tunapokuja kuongelea collision tuna types of collision. Kuna zile collision ambazo zina involve release of energy, lakini kuna zile ambazo no energy released. So wakati wa collision za gas kwenye container anasema it involve the what? Elastic collision. Hence no loss of kinetic energy during collision. Kwa hiyo kumbe hii hii collision inatokea kwenye hizi particle, kwenye hizi random moving of the gas particle ina involve the elastic collision, ambayo hii obvious no loss of kinetic energy. So the way they move, no loss of the energy. Okay, another assumption is the distance between gas molecule is very large, such that the van der Waals forces of attraction is negligible. Kwamba the distance between gas molecule is very large. Ndio maana hata tukifanya demonstration, for instance, I have a container. For instance, I have a container. I can draw here. For instance, I have a container. For instance, I have a container. This one. For instance, I have a container here. This is my container. You see? So within this container, there is the gas here. So you can see that the gas particles will be distance apart. Will be distance apart. So you can see that they are very distant apart. So this, assume this is gas particle. And the distance from here to here, from here to here, from here to here, so they are distant apart. So due to this, they make the van der Waals force to be very low. That's the force of attraction. So therefore, we can return here. So you can see that the van der Waals force of attraction is negligible. Why negligible? Because of that distance apart of the gas particle. Kwa hiyo unakuja kuona kwamba ile force of attraction inakuwa ni ndogo kiasi kwamba tunaweza tukaassume is equal to 0. That's why we say negligible. Kwa hiyo zile gas particle zinakuwa very far. Hauwezi kuzikuta zipo closed together, never. Kwa hiyo unakuta moja kule moja, yani they are distanced apart. So as a result, the gas molecule can move freely independently of each other. Kulingana na hii sasa kwamba zina occupy low van der Waals force or very small van der Waals force kulingana na ile distance apart of the molecule. Sasa hii ndio maana inazipelekea hizi molecule ziwe free kumove independently. Ina maana hazitegemeani kabisa. Each particle ipo yani each particle haitegemei particle nyingine. They move freely independent and not dependent. Kwa hiyo utakuta kila particle ipo free kumove. Another assumption is the pressure of a gas is caused by the collision of the gas molecule with the walls of the container, kwamba pressure of the gas is caused by the what? Collision. Ile collision ya gas molecule ndiyo inakuja kusababisha pressure of the gas. Another assumption is the average kinetic energy of the gas molecule is direct proportional to the what? Absolute temperature. You have to understand this assumption kwa sababu tutakuja kupata overall equation au inaitwa fundamental kinetic equation, lakini pia tutakuja kuitumia kuweza kudrive zile gas laws equation. Kwa hiyo unatakiwa uelewe hizi assumption vizuri. For instance, average kinetic energy anasema kwamba is direct proportional to the what? Absolute temperature. Tutaiona sana hii ikiwa applicable. This means that the average kinetic energy of the molecule is the same at the certain temperature. Kwamba tunapo increase kinetic energy, also we increase the temperature, the way it increases, also the kinetic energy it increase. So this is the figure which show the random motion of the gas molecule in a container, as you see here, my student. Kwa hiyo hii container inaonyesha kwamba ndani ya hii container kuna gas, lakini hizi gas unaona zina move random, they move free, they are distance apart. Kwa hiyo zile assumption zote zinakuja kuwa applicable hapa. The way they move, how the pressure created, the way collision inavyotokea ndipo pressure inakuwa created, they move free, they are independent to each other. Kwa hiyo zile assumption zote overall it can be illustrated by using this container. So my student, after saying all this, I would like to say this marks the end of our discussion. Thank you so much for being with us, Educare TZ. Stay with us for more tutorials.